Network lessons.
What is a network? There are many types of networks that provide us with different kinds of services. In the course of a day, a person might make a phone call, watch a television show, listen to the radio, look up something on the internet, or even play a video game with someone in another country. All of these activities depend on robust, reliable networks. Networks provide the ability to connect people and equipment no matter where they are in the world. People use networks without ever thinking about how they work or what it would be like if the networks did not exist. This picture of the airport illustrates people using networks to share information, use resources and communicate with others. There are multiple types of networks shown in this scene. How many can you find? Communication technology in the 1990s, and before, required separate, dedicated networks for voice, video and computer data communications. Each of these networks required a different type of device in order to access the network. Telephones, televisions, and computers used specific technologies and different dedicated network structures to communicate. But what if people want to access all of these network services at the same time, possibly using a single device? New technologies create a new kind of network that delivers more than a single type of service. Unlike dedicated networks, these new converged networks are capable of delivering voice, video and data services over the same communication channel or network structure. New products are coming to market that take advantage of the capabilities of converged information networks. People can now watch live video broadcasts on their computers, make a telephone call over the Internet, or search the Internet using a television. Converged networks make this possible. In this course, the term network refers to these new multi-purpose, converged information networks. Benefits of networking. Networks come in all sizes. They can range from simple networks consisting of 2 computers, to networks connecting millions of devices. Networks installed in small offices, or homes and home offices, are referred to as SOHO networks. SOHO networks enable sharing of resources, such as printers, documents, pictures and music between a few local computers. In business, large networks can be used to advertise and sell products, order supplies, and communicate with customers. Communication over a network is usually more efficient and less expensive than traditional forms of communication, such as regular mail or long-distance phone calls. Networks allow for rapid communication such as email and instant messaging, and provide consolidation, storage, and access to information on network servers. Business and SOHO networks usually provide a shared connection to the Internet. The Internet is considered a network of networks, because it is literally made up of thousands of networks that are connected to each other. Here are other uses of a network and the Internet. Sharing music and video files. Research and online learning. Chatting with friends. Planning vacations. Purchasing gifts and supplies. Can you think of other ways people use networks and the Internet in their daily lives? Basic network components. There are many components that can be part of a network, for example personal computers, servers, networking devices, and cabling. These components can be grouped into 4 main categories: hosts, shared peripherals, networking devices, networking media. The network components that people are most familiar with are hosts and shared peripherals. Hosts are devices that send and receive messages directly across the network. Shared peripherals are not directly connected to the network, but instead are connected to hosts. The host is then responsible for sharing the peripheral across the network. Hosts have computer software configured to enable people on the network to use the attached peripheral devices. The network devices, as well as networking media, are used to interconnect hosts. Some devices can play more than one role, depending on how they are connected. For example, a printer directly connected to a host, local printer, is a peripheral. A printer directly connected to a network device and participates directly in network communications is a host. Computer rules in a network. All computers connected to a network that participate directly in network communication are classified as hosts. Hosts can send and receive messages on the network. In modern networks, computer hosts can act as a client, a server, or both. The software installed on the computer determines which role the computer plays. Servers are hosts that have software installed that enable them to provide information, like email or web pages, to other hosts on the network. Each service requires separate server software. For example, a host requires web server software in order to provide web services to the network. Clients are computer hosts that have software installed that enable them to request and display the information obtained from the server. An example of client software is a web browser, like Internet Explorer. Computer rules in a network. A computer with server software can provide services simultaneously to one or many clients. Additionally, a single computer can run multiple types of server software. In a home or small business, it may be necessary for one computer to act as a file server, a web server, and an email server. A single computer can also run multiple types of client software. There must be client software for every service required. With multiple clients installed, a host can connect to multiple servers at the same time. For example, a user can check email and view a web page while instant messaging and listening to Internet radio. Peer-to-peer networks. Client and server software usually runs on separate computers, but it is also possible for one computer to carry out both roles at the same time. In small businesses and homes, many computers function as the servers and clients on the network. This type of network is called a peer-to-peer network. The simplest peer-to-peer network consists of two directly connected computers using a wired or wireless connection. Multiple PCs can also be connected to create a larger peer-to-peer network, but this requires a network device, such as a hub, to interconnect the computers. The main disadvantage of a peer-to-peer environment is that the performance of a host can be slowed down if it is acting as both a client and a server at the same time. In larger businesses, due to the potential for high amounts of network traffic, it is often necessary to have dedicated servers to support the number of service requests. Network topologies. In a simple network consisting of a few computers, it is easy to visualize how all of the various components connect. As networks grow, it is more difficult to keep track of the location of each component, and how each is connected to the network. Wired networks require lots of cabling and network devices to provide connectivity for all network hosts. When networks are installed, a physical topology map is created to record where each host is located and how it is connected to the network. The physical topology map also shows where the wiring is installed and the locations of the networking devices that connect the hosts. Icons are used to represent the actual physical devices within the topology map. It is very important to maintain and update physical topology maps to aid future installation and troubleshooting efforts. In addition to the physical topology map, it is sometimes necessary to also have a logical view of the network topology. A logical topology map groups hosts by how they use the network, no matter where they are physically located. Host names, addresses, group information and applications can be recorded on the logical topology map. The graphics illustrate the difference between logical and physical topology maps. Protocol use in communication. All communication, both human and computer, is governed by pre-established rules, or protocols. These protocols are determined by the characteristics of the source, channel and destination. Based on the source, channel and destination, the protocols define the details for the issues of message format, message size, timing, encapsulation, encoding and standard message pattern. Importance of protocols. Computers, just like humans, use rules, or protocols, in order to communicate. Protocols are especially important on a local network. In a wired environment, a local network is defined as an area where all hosts must speak the same language, or in computer terms, share a common protocol. If everyone in the same room spoke a different language, they would not be able to communicate. Likewise, if devices in a local network did not use the same protocols, they would not be able to communicate. The most common set of protocols used on local wired networks is Ethernet. The Ethernet protocol defines many aspects of communication over the local network, including message format, message size, timing, encoding, and message pattern. Standardization of protocols. In the early days of networking, each vendor used their own, proprietary methods of interconnecting network devices and networking protocols. Equipment from one vendor could not communicate with equipment from another. As networks became more widespread, standards were developed that defined rules by which network equipment from different vendors operated. Standards are beneficial to networking in many ways. Facilitate design. Simplify product development. Promote competition. Provide consistent interconnections. Facilitate training. Provide more vendor choices for customers. There is no official local networking standard protocol, but over time, one technology, Ethernet, has become more common than the others. It has become a de facto standard. Standardization of protocols. The Institute of Electrical and Electronic Engineers, or IEEE, pronounced IEEE, maintains the networking standards, including Ethernet and wireless standards. IEEE committees are responsible for approving and maintaining the standards for connections, media requirements and communications protocols. Each technology standard is assigned a number that refers to the committee that is responsible for approving and maintaining the standard. The committee responsible for the Ethernet standards is 802.3. Since the creation of Ethernet in 1973, standards have evolved for specifying faster and more flexible versions of the technology. This ability for Ethernet to improve over time is one of the main reasons that it has become so popular. Each version of Ethernet has an associated standard. For example, 802.3 base T represents the 100 megabit Ethernet using twisted pair cable standards. The standard notation translates as 100 is the speed in Mbps. Base stands for baseband transmission. T stands for the type of cable, in this case, twisted pair. Early versions of Ethernet were relatively slow at 10 megabits per second. The latest versions of Ethernet operate at 10 gigabits per second and faster. Imagine how much faster these new versions are than the original Ethernet networks. Physical addressing. All communication requires a way to identify the source and destination. The source and destination in human communication are represented by names. When a name is called, the person with that name listens to the message and responds. Other people in the room may hear the message, but they ignore it because it is not addressed to them. On Ethernet networks, a similar method exists for identifying source and destination hosts. Each host connected to an Ethernet network is assigned a physical address which serves to identify the host on the network. Every Ethernet network interface has a physical address assigned to it when it is manufactured. This address is known as the Media Access Control (MAC) address. The MAC address identifies each source and destination host on the network. Ethernet networks are cable-based, meaning that a copper or fiber optic cable connects hosts and networking devices. This is the channel used for communications between the hosts. When a host on an Ethernet network communicates, it sends frames containing its own MAC address as the source and the MAC address of the intended recipient. Any hosts that receive the frame will decode the frame and read the destination MAC address. If the destination MAC address matches the address configured on the NIC, it will process the message and store it for the host application to use. If the destination MAC address does not match the host MAC address, the NIC will ignore the message. Ethernet communication. The Ethernet protocol standards define many aspects of network communication including frame format, frame size, timing and encoding. When messages are sent between hosts on an Ethernet network, the hosts format the messages into the frame layout that is specified by the standards. Frames are also referred to as protocol data units, PDUs. The format for Ethernet frames specifies the location of the destination and source MAC addresses, and additional information including preamble for sequencing and timing, start of frame delimiter, length and type of frame, frame check sequence to detect transmission errors. The size of Ethernet frames is limited to a maximum of 1518 bytes and a minimum size of 64 bytes. Frames that do not match these limits are not processed by the receiving hosts. In addition to the frame formats, sizes and timing, Ethernet standards define how the bits making up the frames are encoded onto the channel. Bits are transmitted as either electrical impulse over copper cable or as light impulses over fiber optic cable. Cisco devices has three basic layers. Access layer, to provide connections to hosts in a local Ethernet network. Distribution layer, to interconnect the smaller local networks. Core layer, a high-speed connection between distribution layer devices. With this new hierarchical design, there is a need for a logical addressing scheme that can identify the location of a host. This is the Internet Protocol (IP) addressing scheme. Logical addressing. A person's name usually does not change. A person's address, on the other hand, relates to where they live and can change. On a host, the MAC address does not change. It is physically assigned to the host NIC and is known as the physical address. The physical address remains the same regardless of where the host is placed on the network. The IP address is similar to the address of a person. It is known as a logical address because it is assigned logically based on where the host is located. The IP address, or network address, is assigned to each host by a network administrator based on the local network. IP addresses contain two parts. One part identifies the local network. The network portion of the IP address will be the same for all hosts connected to the same local network. The second part of the IP address identifies the individual host. Within the same local network, the host portion of the IP address is unique to each host. Both the physical MAC and logical IP addresses are required for a computer to communicate on a hierarchical network, just like both the name and address of a person are required to send a letter. Access and distribution layers and devices. IP traffic is managed based on the characteristics and devices associated with each of the three layers: access, distribution and core. The IP address is used to determine if traffic should remain local or be moved up through the layers of the hierarchical network. Access layer. The access layer provides a connection point for end-user devices to the network and allows multiple hosts to connect to other hosts through a network device, usually a hub or switch. Typically, all devices within a single access layer will have the same network portion of the IP address. If a message is destined for a local host, based on the network portion of the IP address, the message remains local. If it is destined for a different network, it is passed up to the distribution layer. Hubs and switches provide the connection to the distribution layer devices, usually a router. Distribution layer. The distribution layer provides a connection point for separate networks and controls the flow of information between the networks. It typically contains more powerful switches than the access layer as well as routers for routing between networks. Distribution layer devices control the type and amount of traffic that flows from the access layer to the core layer. Core layer. The core layer is a high-speed backbone layer with redundant, backup, connections. It is responsible for transporting large amounts of data between multiple end networks. Core layer devices typically include very powerful, high-speed switches and routers. The main goal of the core layer is to transport data quickly. Hubs, switches, and routers are discussed in more detail in the next two sections. Access layer. The access layer is the most basic level of the network. It is the part of the network in which people gain access to other hosts and to shared files and printers. The access layer is composed of host devices, as well as the first line of networking devices to which they are attached. Networking devices enable us to connect many hosts with each other and also provide those hosts access to services offered over the network. Unlike the simple network consisting of two hosts connected by a single cable, in the access layer, each host is connected to a networking device. This type of connectivity is shown in the graphic. Within an Ethernet network, each host is able to connect directly to an access layer networking device using a point-to-point cable. These cables are manufactured to meet specific Ethernet standards. Each cable is plugged into a host NIC and then into a port on the networking device. There are several types of networking devices that can be used to connect hosts at the access layer, including Ethernet hubs and switches. Function of hubs. A hub is one type of networking device that is installed at the access layer of an Ethernet network. Hubs contain multiple ports that are used to connect hosts to the network. Hubs are simple devices that do not have the necessary electronics to decode the messages sent between hosts on the network. Hubs cannot determine which host should get any particular message. A hub simply accepts electronic signals from one port and regenerates, or repeats, the same message out all of the other ports. Remember that the NIC on a host accepts messages only addressed to the correct MAC address. Hosts ignore messages that are not addressed to them. Only the host specified in the destination address of the message processes the message and responds to the sender. All of the ports on the Ethernet hub connect to the same channel to send and receive messages. Because all hosts must share the bandwidth available on that channel, a hub is referred to as a shared bandwidth device. Only one message can be sent through an Ethernet hub at a time. It is possible for two or more hosts connected to a hub to attempt to send a message at the same time. If this happens, the electronic signals that make up the messages collide with each other at the hub. A collision causes the messages to become garbled and unreadable by the hosts. A hub does not decode the messages. Therefore it does not detect that the message is garbled and repeats it out all the ports. The area of the network where a host can receive a garbled message resulting from a collision is known as a collision domain. Inside a collision domain, when a host receives a garbled message, it detects that a collision has occurred. Each sending host waits a short amount of time and then attempts to send, or retransmit, the message again. As the number of hosts connected to the hub increases, so does the chance of collisions. More collisions cause more retransmissions. Excessive retransmissions can clog up the network and slow down network traffic. For this reason, it is necessary to limit the size of a collision domain. Function of switches. An Ethernet switch is a device that is used at the access layer. Like a hub, a switch connects multiple hosts to the network. Unlike a hub, a switch can forward a message to a specific host. When a host sends a message to another host on the switch accepts and decodes the frames to read the physical MAC address portion of the message. A table on the switch, called a MAC address table, contains a list of all of the active ports and the host MAC addresses that are attached to them. When a message is sent between hosts, the switch checks to see if the destination MAC address is in the table. If it is, the switch builds a temporary connection, called a circuit, between the source and destination ports. This new circuit provides a dedicated channel over which the two hosts can communicate. Other hosts attached to the switch do not share bandwidth on this channel and do not receive messages that are not addressed to them. A new circuit is built for every new conversation between hosts. These separate circuits allow many conversations to take place at the same time, without collisions occurring. What happens when the switch receives a frame addressed to a new host that is not yet in the MAC address table? If the destination MAC address is not in the table, the switch does not have the necessary information to create an individual circuit. When the switch cannot determine where the destination host is located, it uses a process called flooding to forward the message out to all attached hosts. Each host compares the destination MAC address in the message to its own MAC address, but only the host with the correct destination address processes the message and responds to the sender. How does the MAC address of a new host get into the MAC address table? A switch builds the MAC address table by examining the source MAC address of each frame that is sent between hosts. When a new host sends a message or responds to a flooded message, the switch immediately learns its MAC address and the port to which it is connected. The table is dynamically updated each time a new source MAC address is read by the switch. In this way, a switch quickly learns the MAC addresses of all attached hosts. Sometimes, it is necessary to connect another networking device, like a hub, to a switch port. This is done to increase the number of hosts that can be connected to the network. When a hub is connected to a switch port, the switch associates the MAC addresses of all hosts connected to that hub with the single port on the switch. Occasionally, one host on the attached hub sends a message to another host attached to the same hub. In this case, the switch receives the frame and checks the table to see where the destination host is located. If both the source and destination hosts are located on the same port, the switch discards the message. When a hub is connected to a switch port, collisions can occur on the hub. The hub forwards to all ports the damaged messages resulting from a collision. The switch receives the garbled message, but, unlike a hub, a switch does not forward the damaged messages caused by collisions. As a result, Every switch port creates a separate collision domain. This is a good thing. The fewer hosts contained in a collision domain, the less likely it is that a collision will occur.